And let's discuss a bit about the agenda for today. So what I planned for you is to discuss about OAuth 2, what it is, its connection with other relevant authorization or authentication frameworks such as SAML or protocols that are built above OAuth 2, which is OpenID Connect. Show you some code in Spring Security and discussing a bit about the ways in which you can implement authentication or authorization with Spring Security, because as I was discussing just before starting our presentation today, Spring Security is not necessarily a difficult to understand framework, but what makes Spring Security difficult to use and learn, and what makes Spring Security having this kind of abrupt learning path is the fact that it changed throughout the time. So if you will take some application from 10 years ago, you will see that it implements Spring Security differently than it does if it is an application that started 5 years ago. And it's again, today we are still discussing about leaving some legacy behind and starting something new. And all these changes that were implemented throughout the time made that if you are now searching on Stack Overflow for solutions or medium.com or whatever other forums, you will find, which all of us do. Of course, we do use these forums a lot, but because the approach has changed so much, now you might get confused on what to use, because you will find articles showing you to do something in some specific way, and then some other articles telling you that that specific way is now legacy and there is a new way, and then you find a next article telling you again that is legacy, and then there is a new way, and we have the legacy of the legacy of the legacy, and that's what makes things really confusing. So I want to discuss a bit about this during the presentation, during our today's presentation. If you have questions, you can ask questions. I keep my chat open in case you want to write in the chat. You can interrupt me as well if you want to ask me something using your microphone. So please do that. Let's have it as a discussion, not necessarily a one-way go. So I'm pretty happy to at least try to answer all your questions, depending on the difficulty of the questions, of course. So yeah, first of all, let's get fast over the slide where I'm just telling you that you can find me in different ways, on Twitter, on LinkedIn. I have a YouTube channel with a lot of content on Java and on Spring and on let's call it the Java ecosystem in general and all its frameworks. And you can also find me on my blog. Of course, you might know me as being the author of Spring Security in Action, a book that I released last year with many publications, and I'm just in progress to finishing my second book, Spring Quickly, which is a book for Spring fundamentals. Yeah, the copy of the Spring Security in Action in its electronic format will be provided to the lucky winner of today's presentation. So as you heard at the beginning, we will share with you a voucher for a free ebook copy of the Spring Security in Action and of a live project. Yeah, let's go a bit. So I skipped the Kahoot. I don't have the Kahoot anymore here because it's a shorter presentation, this one. So that usually I used a nice Kahoot with questions for the participants to get a prize, but now we will skip over it. And we will just go through OAuth 2, the idea of OAuth 2, a comparison with other frameworks, and then I will show you some code. And we will discuss on different things you need to know, and I find them relevant today. Final Q&A, but don't forget that you can ask the questions throughout the presentation, so don't wait for the end. If you have a question, you can just ask it whenever you want. So about OAuth 2 itself, it's quite an important framework, especially today with so many applications starting to become stateless, that they don't maintain a session on the server anymore, or they at least try not to do that. with microservices and service-oriented architectures in general, OAuth 2 is a specification framework telling you how should you implement authorization. And you will see that OAuth 2 actually fits very well with systems that are service-oriented and stateless. First of all, what you need to remember is that OAuth 2 is not an implementation, it's just a specification, which means that different frameworks in different platforms and different languages implement OAuth 2. Like in our case, I will discuss about Spring Security because that's the topic of this presentation. But in case you want to implement OAuth 2 in a system that is designed using a totally different language like Python or .NET, it's such a common way of implementing authorization today that you will find ways to implement OAuth 2 actors in any kind of framework today. So when we deal with OAuth 2, and you refer to OAuth 2, you refer to a specification, not to an implementation. When you say, how do we implement an OAuth 2 system with Spring Security, then what it means is that you will implement one or more components of the OAuth 2 specification using that specific framework. You will see that OAuth 2 has some actors, and these actors can be different applications with their own responsibility. And of course, as you know, in case of microservices architectures, which are polyglottic or can be polyglottic, you might have a situation where one of the responsibilities implemented with Java, but the other one is implemented with a different platform. So that's why even in this case, I wouldn't say that an entire system necessarily needs to be implemented with a specific platform or framework. So you can have a OAuth 2 system where your authorization server, which we'll discuss further, is implemented using Spring Security, and your resource server is implementing using something else, or yeah, whatever. That's the idea. And what it basically helps you is to simply and correctly separate the authentication and authorization responsibilities. So first of all, it helps you decouple these two very important responsibilities such that in the end, you might have only one component authenticating the users and the clients being the applications used by the users, and the application that provides effectively the service. So if you are more familiar, for example, with the SAML implementation, which is something that appeared prior to OAuth 2, in terms of authentication, they were calling that identity provider. And in case of authorization, it was basically what the service provider did, which is the application, basically the backend of the application used by the user. But as you will see, in case of OAuth 2, we discuss about the management of the authorization data being kept and managed by the client, instead of being kept and managed by the server in its stateful session, which means that an important difference in OAuth 2 is that it's more prior to stateless systems rather than the statefulness desired and used by SAML. So you can compare basically these two, but they have differences in both the way they work and what they provide in the end from an architectural point of view. Now, of course, the actors, because if we want to understand better now what we are talking about, we have to take a look on this visual and understand what is the final purpose and who is acting into solving this scene. And the idea is that you have a user, of course, and you as a user, you have to use an application. And in that case there, I used a browser as a client, because in many cases we have web applications today, but remember that the same protocol, the same specifications, sorry, it would have been a protocol if it were OpenID Connect, but we are discussing OAuth 2 here. The whole specification can be applied to no matter what the client is. So in real world examples, you often have mobile applications like Android or iOS applications instead of a web application like in my drawing here. So that's simply just a way to represent the client in my case. But remember, it's anything that the user interacts with directly. So you as a user want to use an application and you try to use a specific use case. And in order to use that specific use case, you definitely need first to be authenticated. So you get authorized. The application needs to allow you or not, give you or not the privilege of using a specific functionality depending on who you are. You might be recorded in your application as a specific role, like you might be an admin, so you can do a lot of things, or you might simply be, I don't know, a read-only user that can only access some data, but they cannot change it. So in order to provide you with the privilege, first of all, the application needs to know who you are and what are your assignments. In this case, this backend of the application is what we call the resource server. And again, it's sometimes referred to as the service provider as well, just because in case of, for example, in case of a SAML implementation, we don't call it a resource server, we call it a service provider. In case of the authorization server, it's called authorization server because in the end, it provides the client with a token that tells the resource server what is the client allowed to do. But in fact, what the authorization server does is mostly authentication. So the flow is this one. When the user tries to use a specific feature through, of course, its client, the client, first of all, needs to be authenticated and get a token that will give them the privilege to obtain, to access resources that are protected by the resource server. So the client goes here to the authorization server. And first of all, the first step is somehow, let's only call it very generically now, somehow the client gets a token from the authorization server and then uses that token to access resources on the resource server. So this token is just like an access card. It's just like if you are a visitor in an office building, you are going to the service desk, you identify yourself using your ID, and then you get an access card, and that access card allows you to access several doors. The access card might help you access some doors, all the doors, depending on who you are. So that's the idea. So many people ask me, why is it called an authorization server since it mostly does authentication? Is because of this card, this access card, the token in our case, technically, but which acts as an access card. Inside it, you have the information that also tells you what can you access, like an access card. So you somehow get a part of the authorization itself with the access card. It's like when you get the access card in the office building, you might be able to open all the doors or only some of them, and everything depends on the card itself. So that's why it's an authorization server and not an authentication server. Then the other part of the authorization is definitely implemented at the resource server side, because the resource server will be the one applying conditions such as if you are admin, you can do that or not. So that if and else based on the access card is still implemented on the resource server side. But now, if you were attentive, we have two main things that compose the flow of OAuth 2. One of the things is step one, how I call it, how to get an access card, how to get the token, and step two, which is how you use the token at the resource server side. So then, of course, at some point, you will ask yourself the question, how does the resource server know that a specific card is valid or not? So that's step two. How does the resource server uses the access token? How does it validate the access token and applies the conditions according to the security specifications? And yeah, that basically I went a bit further into my presentation. So the two steps is getting the token and then validating the token. That's how you want to focus. And now let's take the first one and then the second one, and understand what you need to focus on about the one and the other. And yeah, just because the first step, it depends on the token. So the first step really is really concerned on how this access card looks like. Let's make sure that you have an idea about what a token is before going further. And the token, again, is just, technically speaking, is just an identifier, an information giving you an identification that the resource server can use to apply those security restrictions. In some cases, the token might itself contain data inside. In some other cases, it doesn't. If it doesn't, so if the token doesn't contain any data inside, if it's just a random number, a unique identifier, a string that doesn't contain any kind of a detail about the user, the client, the time when it was issued and stuff like that, we call it an opaque token. And in case it does, in case inside we have details, then we call it a non-opaque token. Of course, opaque because if you don't have no information in the token, it means you can't see through it, so it's opaque. If it has information inside, then it means you can see inside it, then it's a non-opaque token. And today's most of the implementations use non-opaque tokens. And the most used implementation of a non-opaque token is the Jwt, which is the JSON Web Token. But it's very important for me to mention this at the very beginning, because I see a lot of people making confusion about OAuth 2, OpenID Connect, and Jwt. Some people say or consider Jwt is the same as OAuth 2, which is not the case. We need, even if in maybe today 90-something% of the cases we use Jwt as the token implementation, OAuth 2 and Jwt are not equal. They are totally different things. OAuth 2 is the specification. Jwt is one of the token implementations that we can use with the provided specification by OAuth 2. Now, very fast, theoretically, if you have an opaque token, you just get the token, and then the resource server needs to ask the authorization server about the details of the token, because the opaque token doesn't contain information inside. So in case you have an opaque token, when the client gets it, it sends it to the resource server knows nothing about the client because that token doesn't tell it anything. So in order to find out information when you have an opaque token, the only way is somehow get it from outside. And the most used way is the resource server sending it back to the authorization server and calling what is named an introspection endpoint. That introspection endpoint receives the token. If it's a valid token, then it tells the resource server, yes, this is a valid token and this is the information you need to know. That information might include the user and for which the client asked for the token, the client itself, the roles, so on and so forth. So all the details needed by the resource server to apply the security constraints. If it is a non-opaque token, which is the case of most of the implementations today, and let's take, of course, Jwt, because that's what you will most likely find in all the implementations today. This token is a non-opaque token example, which means it contains itself information. So this slide actually shows you how the Jwt token looks like. It has three parts. Always in the moment when it's sent throughout the wire, it is base 64 encoded, just like this. As you can see here, this is a base 64 representation of this JSON here. This is a base 64 representation of this JSON here. And this is a signature created over both these two using a cryptographic algorithm. So the whole idea is that this token contains information inside. To make it easier to separate, the Jwt is split into two parts, the header and the body. Usually in the body, we put all the information we need to use for the security purposes that identifies the user, the client, its roles, and so on. We name these claims. And in the header, we have metadata, such as the algorithm used, key IDs in case we use a public key, stuff like that, which is not necessarily related to the data in the application. And the signature, which is most likely the most important part of the JWT, basically using a private key, we signed this information to make sure that if, while it's in transfer, if someone changes this token, for example, here, let's say I would have had some other role like read-only, and then I change it into admin. If I do something like this, well, I can do something like this, but then the signature won't match anymore. And since I don't have the private key to re-sign the data, then if the token has been altered prior to be received by the resource server, then the signature won't match anymore. And then the resource server will know that something is fishy and something was changed in the token. So it simply doesn't accept the token anymore. So it assures us that the information that is received is always correct, meaning the same information that has been issued by the authorization server who authenticated the user and the client. And then let's see, this is the idea of a token. I have a token, I have this information, I can apply the restrictions, but how do I get the token? How do I actually make my client get this token from the authorization server? And it seems that actually it's not even that easy. So it's not as easy as it looks like. This question has a lot of answers, and these answers are called grant types. And I will just enumerate here the 5 most important grant types, which, again, what a grant type is a way in which the client gets a token from the authorization server. Each of these grant types, each of these flows, they represent each of these grant types represent a flow in which the client gets the token. And we have some of them, like the implicit authorization code password, that is also called the the resource owner credentials. We have the client credentials, and we have a special one called the refresh token. I won't take all of them now because it would take us one day to discuss, and even more to discuss each of these in detail. But I will take the most important one, which is the authorization code. And I will explain the authorization code just because I think this one is the most likely one to get. So I have a question. Do you know if this conference will be available on your YouTube or other channel? We are recording the presentation, so I would say yes, it will be accessible somehow later.
Yes. We will notify the URL it will be available via YouTube, and we'll notify the URL via Meetup. Yes.
Excellent, super, thank you. So yeah, the idea, and what I do recommend, this is a presentation to get you customized with all the details. Of course, OAuth is a complex subject, but I would say maybe not all, but 80% of what I discuss here are demonstrated more in detail on my YouTube channel. So if you are interested on more details than I do present here, I do recommend you follow me and watch the videos and the implementations on my YouTube channel. They will give you a lot of insight.
I'd love to add just one here, Laurentiu. We can easily recommend Laurentiu as well in Twitter, because he's sharing quite often the tips and tricks on security and not only. So to me, following you, it's YouTube and Twitter. That's perfect.
Super. Yeah, thank you very much. I do recommend you that as well. So yeah, let's take only one of these. I would have to tell you that the implicit grant type, if you ever see it used, I don't recommend you use it anymore. The implicit grant type is vulnerable, and maybe you will find it still used in older applications, but instead of the implicit grant type, should always think about using authorization code. That's why authorization code is most likely now I would say maybe the most used, the most encountered grant type you will find. The password grant type is also something that is difficult to use, especially if the client and the authorization server are not part of the same organization. I do recommend that you avoid it as well. So instead of the implicit grant type or password grant type, you should always rely on the authorization code grant type instead. Client credentials is a special grant type that allows a client to get a token without having the privilege of a user. So there are cases where an application needs to call another application without having a requirement from a user. And in that case, you cannot use neither one of the three implicit authorization code or password grant type, just because all the three enumerated in the first 3 points are specifically related to having a user. So if you don't have a user, but you still want to have a way to get an access token because you have an inter-application communication, this inter-application communication can be implemented using the 4th point there, the client credentials. The refresh token is a more special way of getting an access token, but it's a very valuable one. Is, as the name suggests, a way to get an access token if you already had one prior to that. So without needing the user to re-authenticate. They already authenticated, and now you want to be able to get an access token once at a specific amount of time. So refresh your access token without needing to have the user authenticate again. I'm going fast through it. I just want to show you how how such a grant type looks like on a nice sequence diagram. And this is the most, again, as I said, the authorization code grant type, which is the most encountered grant type. Then we will go into the second part, which is how you validate the token. And then once we cover this, we will open some code projects, and you will see how is this implemented in a Spring Security application. So yeah, this is just, imagine the result. What you need to obtain here in this sequence diagram is just that the user needs to use some feature through its client. So it just say, look at the first arrow here. The user just says, I want to access my accounts. So that's a use case in the application. Whatever those accounts are, the user wants to access the accounts. So the result is basically the last arrow on the sequence diagram, where the resource server gives the user the accounts. But in between, to be able to get the accounts, the user needs to prove who they are, needs to get authenticated, and furthermore get authorized to obtain the information. And all of everything you see in between is one of the grant types, so one of the flows that OAuth 2 describes for getting the access. So look how it happens if this application would have implemented the authorization code. When the user wants to access their accounts, but they are not yet already authenticated, the client redirects the user to the authorization server. So what happens is that the client simply redirects to a separate page, to another page that is exposed by the authorization server, telling this way the user, do sign in here at the authorization server side, so I can give you your accounts. And then what the user needs to do is to fill in their credentials, and assuming that they filled in the credentials correctly, then the authorization server in the browser will again redirect back to the client, the previous application, giving them what is called an authorization code. It's not written here, but I'm telling you what happens, okay? So this is where I say, hi client, yes, Katushka, which is the user, allowed you to access her account, which means that Katushka, the user, correctly authenticated. The authorization server sends back to the client what is called an authorization code. Then the client further uses that authorization code and it tells back the authorization server, okay, give me an access token. With this code, I prove who I am, and I prove that I'm the client that Katushka allowed to get her account, so do give me an access token. And then the authorization server gives the client an access token. And then the access token then can be used further to get the accounts on the resource server, aka the service provider, the backend of the application. At the first look, if this is the first time when you see something like that, you will be confused by the fact that here we have a twice communication between the client and the authorization server. So I always get here the question, why didn't the authorization server directly send back the access token? Why sending a code, which then has to be again requested, which then will be replied to with the access token? Why not the access token directly? Because getting the access token directly is actually another grant type, which is the implicit one, which is deprecated. So basically the difference between the implicit grant type and the authorization code grant type is that in the implicit grant type, this arrow here would directly send to the client the access token. And then the client can directly use it. It was, however, discovered that having such a flow is vulnerable. Where is it vulnerable? Well, it's vulnerable because if you would have directly sent through the redirect here the access token, then what happens is that you can fool the authorization server to redirect to a different URL, which can be hacker.com. Considering hacker.com is the URL of a bad guy wanting to steal the access token. And the access token, as you will see, the applications always send it, when they send it in a header, they send it with a prefix called bearer. That bearer meaning, if you have this token, then you can do anything you want. So if you have the token, then you have the key, then you can access the doors. And you don't want someone to steal the token, because if they steal the token, then they can access the doors. So the problem with having the implicit grant type, which is sending back directly the access token, is that you can fool the redirect. That instead of going back to the prior application, it will go to a different site, and that site would steal the token, and then the token can be used to access doors. If you, however, instead of returning the access token back, you return an authorization code, then what happens is that on this arrow here where it says perfect, give me the token, the client has again to authenticate itself, because the client, the app itself, has also a set of credentials. So when they do this call here and they get the response, instead of having a redirect, here the client calls the authorization server, sending the code that proves that they were authorized, but also authenticating themselves with their own credentials to get a token. Which means that if, in case of the authorization code grant type, if someone really steals the authorization code, it's much more difficult to use them, because they also need, besides the authorization code, they will need the client credentials to be able to get a token, which is still not necessarily impossible. That's still basically a little bit of a vulnerability here, but not such as in a case of the implicit grant type, where you could easily directly steal the access token. To solve this little tiny bit of vulnerability, the authorization code implements also a way which is a little bit more complex, called with PXE. The PXE is a secret that is sent on this request, and then that has to be proven on the second one. So instead of using the client credentials, basically for each request we use a different secret, which makes it impossible completely to steal the access token. I won't get into more details about the PXE now, because I would spend too much time. But what I want you to get from this is how such a flow of getting an access token looks like. If you get this flow, it's most likely the most difficult and also the most important because it's the most used. Then you know how is a client getting a token in case of a no auth 2 system. What client refers to in this case? Question, the client means the application you are using. In this case, it can be, for example, your browser in which you have an application like an Angular or a React application, your web application, so the client side of your application, or it can be, as I said at the beginning, mobile app. So it can simply be an application on your iOS or Android. So the client is the app, the client app with which the user interacts. The resource server is the backend of that application, and the authorization server is the component knowing and authenticating the users. I hope I was clear with that. What are the client credentials typically? Something like client ID and secret? Precisely, yes. So that's what they are actually called, client ID and secret. They are not named username and password because username, it would mean a user. It's the username of a client is the client ID. And then we don't call it a password, we call it a secret. But the client ID and the secret is the set of credentials that identify the client. Exactly. Cool. So now step 2, and then we are getting into code. As I was saying, if now we are on the other side. So what we want to discuss now here is the client trying to validate a token. If you have a token that is opaque, which means it doesn't contain information, unlike the JWT, it doesn't contain information, then the only way to get it is to somehow get the information from outside, which is, in case of an opaque token, most likely the resource server calls an introspection endpoint on the authorization server to get the information about the token. In case there is a JWT token, a non-opaque token, and the JWT, as you have seen, it uses a cryptographic algorithm to sign the token, then what happens is that you can have a key that can be used to validate the signature on the resource server side, and then you don't need to have a communication between the two components anymore. It's simply the client gets the token is signed with a private key, and then the resource server validates the signature using its public key, and all the information is already inside the token, so it doesn't have to call anyhow externally or call the authorization server to get the information because it already contains the information being a non-opaque token. So this is most likely why this approach is so often used today, and it has a lot of advantages above the introspection and the different way that is called blackboarding. I won't discuss about it because it's anyway not recommended. But this is most likely 90 something, almost 100% of the cases today, the approach you would use to implement OAuth 2. So in the end, you will have a JWT token issued by the authorization server, signed with a private key, and then the resource server simply has to get the information from inside the token after validating that the signature is correct. Because validating the signature is correct means that indeed no one altered the token while it was in transit from the authorization server to the resource server. With crypto signature, how do we manage the revocation? So basically, that's actually a very good question. So to revoke a token, which is an action meaning to not use it, to deprecate the token, to expire the token, what we can actually do is, first of all, one of the solutions would be to store the revoked tokens somehow. But that would mean that the access token would need to continue to make introspection, so it's not quite a good approach. The best approach is to use key rotations. Key rotation, which is something that you anyway have to do at a specific amount of time, is changing the private key used to sign the token. So in case you want to just invalidate a token, you basically will invalidate a bunch of tokens that were signed with the current key by changing the key. So that means those who got the last tokens will have to re-authenticate, which is not such a big deal, because in the end it simply means that they will have to re-authenticate. But if you know that someone stole the token, then they will not be able to use it anymore, because the signature on that token wouldn't be correct anymore. So that's a very simple way to implement revocation with crypto signatures, with the crypto signatures approach. In most cases today, the keys are only managed at the authorization server side. So that means that the resource server calls an endpoint, which is called the keys endpoint, to get the keys, the public key itself, which means that the key rotation has only to be done here. You replace the pair of the keys here, and then automatically the resource server will get the new public key. So it's a very comfortable and approach that it takes not much effort to do. It's only a change of configuration on the authorization server. Okay, and let's go now to take a look into some projects. So I already prepared some projects, because if I were to write them now, it would have taken me a lot of more time, but we will just look a bit through the code to understand how Spring Security deals with implementing an authorization server and then a resource server. And what I want to tell you from the very beginning is that at the moment, we have no way to implement, no proper way to implement an authorization server with Spring Security. Because how would we implement the authorization server with Spring Security today would be using a project that is named Spring Security OAuth, which has been deprecated last year. So Spring Security OAuth is not theoretically supported anymore, and you are not recommended using it anymore. Unfortunately, the Spring Security team deprecated this project before having an alternative. So what happens today is that you have only two real approaches that you will find in practice. One of them is old applications who implemented themselves the authorization server using Spring Security OAuth, which looks like this, and I will explain it to you in a couple of minutes. Or use a third party such as Keycloak, Auth0, Okta, or Cognito if you have an AWS account and you use AWS, and so on and so forth. What I can say is that if you want to implement an authorization server for your system today, most likely now the best approach is to use a third party and not to implement a custom one. But you will find that applications who implemented the custom one use now this approach, which is considered to be legacy. The Spring Security team started the implementation of a new authorization server, which is now version 0.10 or something like that. I will show you an implementation with a version of a couple of months ago, 0.03. Unfortunately, this new authorization server is not yet finalized, which means we don't have a mature version. We don't have a version that we could use in production for this one yet. My personal opinion is that we won't have one by the end of the year. So we are quite into a difficulty here if you need to implement a custom authorization server. For example, I'm in this situation on one of the projects I'm consulting. Our client doesn't want to use Keycloak or Okta or something else. They want to implement their own authorization server. So what do you do in that case? My solution was, and it was accepted, to postpone the implementation, because I want to have first the experimental authorization server no longer experimental. I want to have it in a mature version and then use it for that. Otherwise, you don't really have an option rather than using the deprecated solution. And the deprecated solution is still something you need to learn. Why? Because, well, if you now take a look on an application that implemented their authorization server, you will basically see that they use this legacy now approach, which means depending on the project you are working with, if you want to understand it, then you would need to know this approach as well, which is part of that difficulty of using Spring Security that I was talking about at the beginning of the presentation. So this is how it looks like. For example, never do like me, never use auto wiring on fields. I do this only in example and proof of concepts because I'm lazy. But in a real world scenario, do always use injection through the constructor. So in the case of what we call the authorization server or the Spring Security OAuth authorization server, so the legacy approach, you would basically extend this authorization server configure adapter class, and then it's a very simple way of configuring the clients, and the users are simply taken from the user detail service, which is not which is something that say a common approach that you would use for any kind of application, being it OAuth or not, for implementing authentication with Spring Security. So having a user detail service and the password encoder are the contracts that you implement to define the user authentication in any Spring Security application. In a real world example, of course, you'd have an implementation that takes these details from a database. You can even have a situation where you can take them from something like an LDAP or something like that, an AD. But the idea is that you would most likely only in examples use the in-memory approach. But the implementation is the same. So once you have implemented your user management and you have implemented your client management, this is what you're asking me about. Someone a few questions before. This is the client ID and the client secret. And then you, of course, configure the grant types. You say this client can use the refresh token and the password grant type, or they can use the authorization code grant type, or the implicit grant type, or the client grant type, the client credentials grant type. And the scopes, which is kind of, you can imagine them as being some roles, but at the client level. So yeah, this is basically once you implemented the user management and the client management, then basically that's mostly it. You can actually also, if I'm running this one now, this doesn't produce me any kind of JWT. This is an opaque token implementation, which is the default implementation for Spring Security OAuth. But then you can implement what is called a token store, and the token store tells the application how to produce the token. And fortunately for us, there is a so-called Jwt Token store implementation directly provided by Spring Security. And you simply have to plug in an instance of the Jwt Token store, and it automatically starts generating non-opaque tokens for you. So you only have to give it the private key, and it signs the token, and that's it. So that's a quite simple way to implement with Spring Security OAuth. Basically, these two classes of 40 and 40 lines of code each would basically be the implementation of an authorization server. So it's all a thing of implementing the client user authentication and then the tokens, and that's basically it. If you use Spring Boot, you can also configure these values in application YAML. Yes, I do agree with you. I do prefer, however, in my examples to use code, because when I use YAML or properties, I just write some properties there, and then it's so transparent what happens behind the scenes that developers at the beginning of their road to Spring Security, they don't realize that basically those properties in the YAML file, what they actually do is telling Spring Boot to create these bins. So in reality, when you put those properties in the YAML file, it basically happens what I'm writing here now, but just out of the box, because Spring Boot is configuring them. Spring Boot, that's what Spring Boot does actually. It's a convention over configuration. So you write the properties, it implements the convention. You don't have to write the bins yourself. But what concerns Spring Security is basically that you need to know which bins behind the scenes are used there, which might not be really helpful to see if you simply use those properties in the application file. So that's why I'm showing you the beans and not the application properties file configuration. Now, I would like to show you how it looks like the new approach. So if you would implement the authorization server with the new approach, then it will look like this, which you will see is pretty similar. So first of all, the same way of implementing the authentication using the user details service and the password encoder. And then we have a little bit of a change in case of the new authorization server. You will see that we have this new object called the register client repository, which is the manager of client data, meaning the client ID, the client secret, which grant types are supported. A very interesting thing, you will see that the grant types now are given by an enumeration, which is it was a very bad class design in Spring Security OAuth. The fact that you could basically just put any string here, and it was very funny for me to observe that in some cases people didn't even know what the grant types were, and in some projects I've done consultancy for, I've just seen people adding strange values here that didn't mean anything just because that's how they found it on a specific article on Stack Overflow, and it was still working, because if I'm just putting here ABCD, then it's, since I have also the password and I'm using the password, my implementation won't take that into consideration, but it's just strange to have it there. And it was, again, one more sign that to make it clear for me that people don't understand and can't properly use articles over the net when it comes to Spring Security, which is pretty uncomfortable, because security is quite important. So if you don't understand what you are writing here, I would feel uncomfortable if I have to implement something like a security capability in my application, but I don't understand how I do that. I just copy something from Stack Overflow. With security, you shouldn't play, and it feels like if you do that, and I've seen people doing that, it's just playing with the fire. So what you will find out that the new authorization server that hopefully will be out pretty soon, it enhances a lot the class design and the features. It allows you not only use OAuth, but also a protocol that is defined over OAuth, which is called OpenID Connect. It implements the possibility to revoke token, to define more easier the custom claims on the token, like the token time to leave. It allows you to define if you want to reuse or not the refresh tokens, which was not possible in the prior implementation. Unfortunately, we still have to wait for the first mature version. But what I can advise you do is what I also did and I'm doing is I'm constantly trying to use the new versions that appear, and I'm even contributing to this project. I've committed my own lines of code there, and I will do the same as long as I have the time, because this, when it gets out, this will be the new way everyone will use to implement custom authorization servers with Spring Security. And it makes the things very easy, and it allows you to implement basically, I would say, almost everything you need from an authorization server without needing to configure a third-party, custom third-party if you don't want to do that. Then, of course, you would have the resource server, and again, the resource server, same as the authorization server, it has a legacy, and the legacy approach is the one in which you use the Spring Security OAuth project, where you would basically have to use the enable resource server annotation. There is one more class here, which is called resource server. This project I didn't need, but you would need if you want to configure it. You have the resource server configure adapter class, and that same extending it, you can override the configure method and you can customize your resource server. But mind that this is part of that Spring Security OAuth. You can see it in the packages here. And the Spring Security OAuth project is the one that became legacy. So what happens today is that the Spring Security team tries to pull out this functionality from the Spring Security OAuth and directly put it into Spring Security. And that's why, and I'm showing you now the migration of the project to the new non-legacy approach. Instead of using the enable resource server and the resource server configurer adapter of the Spring Security OAuth project, you would use something that is called a DSL method. A DSL method, I'm sure if you have used at least once Spring Security, you have seen maybe HTTP basic or form login. These are called DSL methods. Okay. And this DSL way of configuring the authentication is the new approach, the last approach, the one recommended today. So if you want to configure authentication, you just use one of the provided DSL methods by Spring Security. The simplest one, which you find in all the examples, is HTTP basic. The form login provides you a nice login. There is one for OAuth 2 as well. There is one if you want to create an OAuth 2 client. There is another one if you want to implement SAML. So there is a DSL method for any kind of authentication implemented with Spring Security. And if you want, of course, to implement a resource server, then you use the one that tells you you are configuring a resource server. So instead of having a separate dependency in your POM XML file, you directly configure everything related to the authentication through Spring Security. And then you only need a Spring Security dependency. You use the right DSL method, depending on what authentication you would like to configure, and you configure that authentication. So if you are now implementing a resource server, you should go through this approach and not through this one. This is the legacy one. You will find it in older applications. If you today implement an application, you should use the DSL approach. That's basically it. And with that being said, I would like to close here, because if it were for me, then I could basically speak an entire week about Spring Security. To provide you some learning resources, again, you will find many hours describing this and implementing what I have shown you on my YouTube channel. You find the examples in Spring Security in Action, the book as well. And if you are interested in learning more about the specification itself, there are a couple of books from Manning that detail them nicely, aside from, of course, the specifications you find online yourself. OAuth 2 in Action and OpenID connection, which is the protocol above OAuth 2 I was talking about today. Otherwise, thank you very much for listening to me, and I'm still waiting for your questions if you have questions.
So, hello everyone, Radislav again here. If you have questions, you can choose either write them in the chat, or you can ask them, you can connect your microphone and ask them live. In the meantime, I'm going to use the list of participants, and for that I will share my screen, and then we can use the random work to see who is going to get the how they're called, the code for ebook Spring Security in Action, and the code for live project on manning.com. And this is what we are going to do now. A moment. I'll share my screen. For some reason I don't see the screen. Ah, voila. Okay. Good. Please tell me if you see my screen. And normally you're supposed to have the you're supposed to see the how it's called, list of participants.
I can see the screen at least. So
now let's take the list of participants so far. We'll put them in random org and we'll say randomize. So the first part, Jean-Timothée Lagors and Lalit. Hopefully you're here. So Jean-Timothée and Lalit, you're going to get Jean-Timothée, I'm going to send you the code for the ebook, and Lalit, hopefully I pronounce it correctly. Yes. I'm going to send you the code for a Manning Live project, and I can send you live in the chat if that's fine for you. In the chat in how it's called, in Zoom, or do you prefer it by email?
You can send them by email or in chat. Just
I don't have the email. That's why. If you want me to send you by email, I'll need yours. But I will send you in chat here, and then if you want, you.
Yes, I get it. I get it.
Okay, fine.
Thank you very much. One more thing. If you read the book, and hopefully you will read the book, and if you like it, don't forget to also leave a review for me. That helps me as well. That's of course varied for everyone that attended. Hopefully you like the presentation. You can find me, as I said, also on YouTube, Twitter, and LinkedIn, and ask me questions there if they come later. So don't hesitate if you have a question. I know tonight you sleep on it and you have a question tomorrow, then you can still ask me. So.
And yes, just a moment, Jean-Timothée, I'm sending you as well via chat in a private message. Please, Lalit, can you confirm that you received the link and the code?
Yes, I received the link. Yeah.
Okay, so you have it in the chat, and Jean-Timothée, you have it here. Okay, so thank you, everyone. Thanks a lot for the participation. Thanks a lot, Laurentiu, for this great talk. And see you soon on our next meetup, which will be happening soon. You can check the meetup meetup.com for the software craftsmanship Luxembourg, and you will see the next events. Subscribe, and you'll be notified as soon as possible.
Thank you, everyone. Again, have an excellent day further. Cheers. Bye-bye.
Bye. Cheers.
Thank you for.
Bye.